Here is the next example. In this example, here he's asking about find the total state response of a given model. I also found the total output response. I'll show you at the end. So here he's asking about total state response. So here is the given model. Okay, he gave you input and initial conditions. Okay, so A matrix, B and C is 0 and 1. Now the formula for total response is x of t equal to phi of t, which is state transition matrix, times initial condition plus phi of t integral of 0 to t phi of minus tau b times u of t d tau. Okay, so this is zero input response. So when the input is 0, that's the response. This is the zero initial condition response. Okay, this derivation I showed it in another video. Please watch that video. Now we'll find the state transition matrix phi of s equal to Si minus A inverse. So I found phi of s equal to s over s plus 3 over s plus 1, s plus 2, 1 over s plus 1, s plus 2, 2 over s plus 1, s plus 2, s over s plus 1, s plus 2. So what I did the partial fraction for each and every term. All those here is all the 4 terms. So once I did the partial fraction, I end up with phi of s equal to 2 over s plus 1 minus 1 over s plus 2 minus 1 over s plus 2 plus 1 over s plus 1, 2 over s plus 2 minus 2 over s plus 1, 2 over s plus 2 plus minus 1 over s plus 1. So that's phi of s. Now I found phi of t by using the inverse Laplace transformation. So this is state transition matrix. Okay, now we're going to find the zero input response. So when I said zero input, u of t equal to 0. That's what zero input response, u of t equal to 0. So x of t equal to phi of t times x0 with initial condition. So initial conditions we have minus 1 and 3. So phi of t is 2 by 2 matrix. This is 2 by 1 matrix. So these two are same. So we'll end up with 2 by 1 matrix. So that's what it is, 2 by 1 matrix. Okay, you do the calculations, you verify this multiplications. Okay, I did it a couple of times, so I'm assuming these numbers are right. Now we'll see the zero state response. Here zero state response is nothing but assuming initial conditions are 0. So here I'm assuming initial conditions are 0. Okay, so if I assume the initial conditions are 0, this is the formula, x of t equal to phi of t integral of 0 to t phi of minus tau b u of t dt. Now phi of t is known. This is phi of t. Okay, now I need to make it as phi of minus tau. So wherever I have t, I'm going to replace this with minus tau. So 2e to the power of minus t becomes 2e to the power of tau. So every t is replaced with minus tau. Okay, and b is 1 0 and u of t is 3. That is given. So I did the multiplication. I end up with inside the integration. This is what I end up with. Now I'm going to substitute, integrate each individual term. So e to the power of at integral from 0 to t, that will be 1 over a e to the power of at minus 1. Okay, now if I follow that, the integration, I end up with, this is the after integration. Okay, now I simplified it. This is what I end up with. Then x of t equal to phi of t times this matrix. So once I multiplied, I end up with this is the x of t. So here this is zero state response. So now the total response is nothing but zero input response plus zero state response. So when I added them together, x of t equal to e to the power of minus t. So this is the zero input response. So this is zero input response and zero state response. So when I added x of t, I end up with this. Now output response, as I mentioned, I'm going to show you output response. Output response is nothing but y equal to c times x of t. I already know c value, which is 0 and 1, and x of t, this is the total response of the given model. Total response of the given model. So when I multiply, this will be the output for the given model. I just skimmed through the example within 6 minutes, but when I solved it, it took me more than 30 minutes. So make sure, in the exam, definitely I will ask at least one or two similar example or part of this example, similar example. So make sure that you practice it enough. Make sure the multiplication is right, and if you made a small mistake, that will escalate a bigger mistake at the end, big error in the end. You will lose lots of points. Okay, I will stop it here. Thank you.